We're going to start this section with a review of Python's built-in data types. These are objects that you're going to use all the time in Python, and just want to kind of quickly cover the basics of them. Let's just do a little demonstration here. One of the core data types that you might work with is something known as a tuple or tuple. Essentially what a tuple is it's a bunch of values packed together into a single thing. Like what I'm doing here is I'm making a tuple that has a name, a date, shares, and price. And what you'll find is that the result is an object that holds all four of those values. Under the covers, it looks a little bit like an array. So it has a length to it. You can index into it to get different values. You can even perform calculations with some of the values and so forth. But the key thing is that you've taken these values and kind of packed it together. A few notable things about tuples. One mental model is they are kind of like a row in a database or a row in a file. Think about them as records. It's like you have a record, it has multiple parts to it. First name, last name, street address, zip code. That's kind of the mental model on a tuple. Another notable thing about tuples, typically when you work with them, you're thinking about packing and unpacking. Turns out that this initial step of creating a tuple, what I was doing was packing values together. One of the things that I can do is unpack the values. I can do an unpacking step, and I'll get all four values placed into separate variables. Tuples are also immutable. Turns out if you make one of them, you can't change any of the values. Once you've created it, it's kind of fixed or frozen in space, if you will. So this is the first data type, Python's tuple object, a bunch of values packed together. Another data type that is used a lot is Python's list object. Essentially, a list is a bunch of items. Maybe I have a list of stock names or something like that. Again, it works like a little array, so you can get a length and you can index into it. But what's going on with a list is it's actually something that you can modify. For instance, you can append things on the end of a list. You can insert things in the middle. There's all sorts of things that you can do to change the data that's in a list. You can freely overwrite any of the methods or any of the items. So if I wanted to change one of the entries to something else, I can certainly do that. So this is another core data type, maybe a list of data. One thing to note about lists, as opposed to tuples, is that usually with a list, all of the items are of the same type. Like you might have a list of strings or a list of numbers or something like that. It's very common when building lists that all of the items would all be of the same kind of item. That becomes more important later when you start to do data processing on it. It's kind of a notable distinction between lists and tuple. Here you have all the same kind of thing. When you make something like a tuple, you have one record, it has multiple parts. The different parts might actually be different kinds of data. So that's another built-in data type, Python's list object. Another type that turns out to be useful is Python's set object. The way that you write out a set, I'm going to write something called distinct names here for reasons that will become apparent in a second. You use a curly brace, and then you put a bunch of items in there. And one of the things about sets is that they eliminate all duplicates. If you had a collection of names like that, notice that I've got IBM and Yahoo repeated a few times. When you make a set, all of those duplicates will just disappear. So what you're going to get with a set is you get a collection of just distinct items or unique items. And one of the main uses of a set is actually in problems related to that. Like you might want to deduplicate data or eliminate duplicates from a data set. Very easy way to do that is to take it and turn it into a set. Like if I were to say set out of names, you would see IBM kind of drop out of there once. So it's just giving me the unique names. The other thing with sets is they're very often used for sort of membership testing. Like once you have a set, you might use something like the in operator to tell you whether something is in there or not. And if it is, you'll either get true or false. So sets, very useful, again, for problems involving like duplicate detection, membership testing, that kind of thing. The final data type I thought I would mention is Python's dictionary data type. Essentially, a dictionary is a mapping where you have keys mapped to some other value. What I'm doing here is maybe making a mapping between stock names and the prices of those stocks. So I'm building up a little data structure like that. What this is going to allow me to do is to do fast lookups. I could say price is IBM, and it would tell me the price of that, or the price of AA, 32.2. It's a very easy way to kind of do these like lookup problems. You also get some of the features of sets as well. It turns out that if you have a dictionary, The keys can only be in there once. Like if you try to reassign a new value, it will replace the value that was already there. And then you also get some of the features like the in operator for membership testing. So in some sense, a dictionary is kind of like more than a set. It's like a collection of names, and you have values attached to those names. Having introduced these sort of 4 core types, tuples, lists, sets, and dictionaries, it turns out that you can solve a huge number of data analysis problems just by doing different combinations of these objects. One of the things to kind of note is that you can build data structures out of almost anything. For example, if I wanted to have a list of items that consisted of tuples, for instance, that is perfectly fine. You can make a list out of anything that you want. So if you wanted a list of tuples, that's okay. If I wanted to do, a more complicated dictionary, like let's say I had a prices dictionary where the key was the name of a stock, but then the item in here was like another dictionary. Maybe you had something like the current price and the high price and the low price. Python is fine with that. You will look up IBM and then it will give you back a dictionary, and you can do different combinations of lookups and so forth. So what we're going to see in kind of the next part, how to utilize that to read data from a file and do more advanced calculations.